Hello, ladies and gentlemen. Today we're going to do three different sections, as you can see here. Evaluating simple probabilities, the probability of and, when you see and in the directions, and also or in the directions. You can ignore this for now. And are so easy that typically we don't require a formula, and that's sort of in the wrong place anyway. So three different sections. The notes won't be any longer than usual, though. This first piece we actually spoke about a little bit last week. A singleton, something's called a singleton if there's only one way the event can occur. So, for example, if I ask you what the probability of rolling a 3 on a die is, that 3 is a singleton event because there's only one outcome. You'd say the probability was 1 out of 6, and if you listed the outcomes, you'd list 3. 3 is the only 3 out of 3 that you can get on a die. So that's what singleton means. It's used in the direction sometimes. Here's the real business we spoke about on Friday. All probabilities must fall between 0 and 1. Probabilities are fractions, and if the event happens every single time, we have a value for that of 1, and if it never happens, for example, the probability that you go to school on a Sunday, that probability would be 0, because it just simply never happens. So this is the way we would write that mathematically. The probability of an event has to be between 0 and 1. The probability of all events. So if you have a probability of 3, it's just not right. It's got to be wrong, because all probabilities, you can't be more likely to happen than perfect every time, which is 1. And that's what this says here. An impossible event has a probability of 0, so the probability that you'd go to school on a Sunday is 0. The probability of rolling a 7 on a die that only has 6 sides would be 0. A certain event has a probability of 1 if it happens every single time. So this is a certainty. It says certain right here. It's an absolute certainty. The probability of rolling less than 7 on a die would be 6 out of 6, which is 1. Don't leave an answer as 6 out of 6. For goodness sakes, that reduces to a 1. Alright, and. So see, that's it. We're all done with that section. We're on to the next. And. The events have to occur simultaneously in order to be counted as an outcome. So, for example, probability of an even and less than 3. Well, on a die, the evens are 2, 4, and 6. The numbers less than 3 on a die are 1, 2, and that's it. So, the probability of it's an even and less than 3, we know it's something out of 6, because when you roll a die, there are 6 total outcomes. Well, how many numbers appear in both lists? I have a 2. That's it. So, there's only one number that is less than 3 and also even at the same time when rolling a die, and that is the number 2. That is the only outcome that satisfies both parts of this probability. For number 2, an odd number and the number is 4. Well, odds. What are the odds? 1, 3, and 5. The number is 4. Well, that's not very hard to figure out. There's only one outcome where that's the case. It's the number 4 itself. We want this to happen at the same time. There is nothing that is common in the list. These are called mutually exclusive events. They have nothing in common, and 0 out of 6 or 0 would be the probability here. Okay. Now, if we had to list the outcomes, we would list the empty set, because there's nothing. There are no odd numbers that are the number 4. It just doesn't exist, not only on this die, but in the universe. Okay, you're rolling your die. You want to get greater than 3, so you're looking for a 4, or a 5, or a 6. You want that also to be less than 6. So less than 6 would be 1, 2, 3, 4, and 5, or less than 6. Alright, so greater than 3, 4, 5, and 6, less than 6, 1, 2, 3, 4, 5, 6. Or, sorry, 1, 2, 3, 4, 5. Alright, so what do they have in common? 1 and 2. Numbers that are greater than 3 and less than 6 are the numbers 4 and 5, and this probability is 2 out of 6, or 1/3. Example 4 here. Even and less than 6 and greater than 1. Oh boy. Well, let's list our evens. 2, 4, and 6. Less than 6. 1, 2, 3, 4, and 5. Greater than 1, 2, 3, 4, 5, and 6. Anything in common in here? Well, I see something. I see a 2. And I see something else. I see a 4, and that's it. So the numbers that are even, 4 is even, 4 is less than 6, 4 is greater than 1, and 2 also. Whoops, I have my order a little messed up. 2 is even, 2 is less than 6, 2 is greater than 1. The probability that your roll has all three of those features is 2 out of 6, or 1/3. Alright, moving on. Last section, OR. Okay, OR. Now we have our first formula that we have to memorize, and I'll be honest with you, there's only about 3 formulas in the chapter. The probability of A or B must be memorized. You take the 2 individual probabilities, you add them together, you figure out if there's any repeats, and you subtract out the repeats. The probability of A and B are repeats and have to be subtracted out. So let's see an example of this. Probability of an even. Probability of even on a die, well, the evens are 2, 4, and 6. The probability less than 3 would be 1 and 2. So for an OR, we just add them together. So the probability of A is equal to 3. And 3 out of 6. The probability of B is 2 out of 6. So we would say, hey, the answer is 5 out of 6, box it up and move on. But that is not right. And it's not right because we counted the number 2 twice. We have to take it out. Okay? The probability of A and B is 1 out of 6, and we have to subtract it out. So we're left with 4 out of 6. The answer is 2/3. Alright, let's look at example 6 here. See if we can make this a little bit more clear. The probability of a king. The probability of a king on a dice, or on a, obviously not a dice, or on a deck of cards, there's 4 kings out of 52. An ace, 4 out of 52. We add them together, you get 8 out of 52, but you don't stop. Because you want to know, is there probability of getting a king and an ace at the same time? What is that? Well, can we pull out one card, and that card shows like king on one part of it and ace on the other? And the answer to that is no, it is not. It's impossible. So we subtract 0 out of 52 out, and it turns out we were okay. This is 8 out of 52, which is, let's see, divide by 4, 2 out of 13 would be the final answer. Alright, number 7. Red card in a deck of cards, 26 out of 52. Ace, 4 out of 52. So we're going to add those together to get 30 out of 52. You turn that in, it gets marked wrong. Question is, why is that marked wrong? The answer is too big. The probability is not 30 out of 52. Why not? There's a couple of repeats in there. The ace of hearts was counted twice. The ace of diamonds was counted twice. There are 2 repeats. I have to subtract them out. 28 out of 52 is the correct answer, which is 7 out of 13. So you have to subtract them out. Well, here's a problem here that just gives us the A, B's, and the C's. You take the probability of A plus the probability of B and subtract the probability of A and B. That's 0.7, which is a number between 0 and 1. So it's good. Alright, we saw an example earlier. The disjoint and mutually exclusive. Nothing in common. 2 or 3 on a die. Is that mutually exclusive? Well, when you roll a die, if you get a 2, can you get a 3 at the same time? Simply, it's impossible. So, are they mutually exclusive events? Yeah, because it can't happen. Mutually exclusive means you cannot get it to happen. If the probability of getting a 2 and a 3 at the same time is 0, then it should be considered mutually exclusive. Can you get an odd or a 3 with one roll of a die? If you roll a 3, it certainly is odd, so this is not mutually exclusive. We saw an example of mutually exclusive before. We actually had another example up here with the ace and the king. Probability of ace or king, which I've erased, but you'll remember it was 4 out of 52 plus 4 out of 52 minus 0 out of 52, and that 0 is because king and ace are mutually exclusive. You can't get a king and an ace at the same time. They're mutually exclusive events. Okay? Alright, we're going to do 3 different pages here. You'll notice there's not a ton of problems in each page, though. You should get your chapter test back tomorrow, and we're going to go over that as well. Have a wonderful evening. We'll see you tomorrow.